Hello and a big welcome back to all my subscribers, and if you're not a subscriber, what's wrong with you? Today I wanted to show you a little project that I'm prototyping, a binary clock that I want to make into a desktop clock for myself. Now what I've done is I've programmed a Nano so that it does a binary clock, as you can see, with a date and time. It's got a small piezo speaker and two buttons for doing things. One of the options is if you press it twice, it goes into settings mode. I'm sure this is very difficult to see, but here you can set the minutes with the left button, and if you press the next button, it moves on to hours, and then you can set the day, the month, the year, the Pomodoro timer, so it will do Pomodoro functions and it'll set an alarm when your time is up. And then you can set an alarm, hour and minute. And then you can pick the color of the pips, the little dots. Maybe we can pick one that's a bit easier to see on the screen. And you can pick the background color. Go with black, and then exit setup, and it's changed it. So basically it's just a binary clock, but it has some additional functionality which I've put in. If you press I think it's this button, the Pomodoro timer will start. I've set it to 1 minute. I've basically set that in the code as a default in order just to test it, so that I can see what's happening and listen to it. Now, normally a Pomodoro timer is 20 minutes, and this, obviously, the default I will set back to 20 minutes. I'll show you in the code that this plays a melody as its alarm. I think it's a small world, I think, is what the sound is. So I've got 19 seconds left. I can see it on my serial port monitor before this thing kicks off. So I just wanted to say that one of the things that I want to do next with this is to put it on an ATtiny chip. Right, and then this button will cancel the alarms or timers or anything like that. I do want to put it on an ATtiny chip rather than this, because I'm 3D printing a clock mount for it. So the idea is that I will put all of this into the clock mount. The only thing I have yet to test is I need to blow this onto a ATtiny, or perhaps, if it doesn't have enough memory, onto an ATmega chip. I prefer the tiny just because it's less room. This is a ATtiny 84 rather than the larger chip, but it just depends on the memory. It's got enough pens and things, but it's the memory. Now, the one other thing which I don't have on here yet is a real-time clock chip, which I have on order, but I'm probably not going to get that. I've ordered it in from China. That's going to be a while, but that will be part of the final assembly that goes into the actual desktop clock. So let me show you some of the code. And basically, you can see the timer was running there. Let me just move that out of the way. So I'm using the Adafruit libraries and some debouncing, and pitches is the melody for the sound the buzzer plays. So that is the alarm. I set a load of default options at the top here. The first one being the default text size and things like that. And then Pomodoro timer, which was set to 1, but we'll change that back to 20. It defaults the colors, but it will allow you to pick pip colors and background colors in the settings. You can't change the note, but I'm alright with that. It's fine. It's mostly just for me anyway, so it's not a problem. But there's functions for handling normal mode, which is the clock, handling setup mode, draw the setup screen, and the binary clock, and then just update the clock. Now, at the moment, this update clock function just uses the internal clock of the Nano, but as I said earlier, I will change that to a real-time clock when I get the chip. Everything else is relatively straightforward, but this function obviously will change when I get the clock. That's pretty much it. When in normal mode, it just debounces left and right. It'll turn on it'll play the alarm, but I had to have a way to cancel the alarm, so it will cancel the alarm, stop the buzzer, all of that good stuff. But normal mode here, basically, if you push the left button, it turns on the Pomodoro mode, and if you push the other one, it turns off the alarm. So it'll stop all alarms. And then setup mode, slightly more complicated. It's basically running you through the options, changing the defaults up above for minutes, hours, days, alarm time, pip color, and background screen, as you saw. And then there's a draw setup screen, which basically just shows this stuff. Probably needs a bigger text size because it's a bit small. And then there's basically the loop, and in the loop all it's really checking for is whether there's a Pomodoro clock running or is it in setup mode. And if it's in any one of those, if it's in setup mode takes over and has its own while loop to block this particular loop. And as I said, you can switch pip colors to white, blue, green, yellow, red, or background color white, blue, green, yellow, red, or black. The default here is black, the default is white on the other. And then the binary clock is drawn just a set of circles, filled circles representing, when that particular binary value is a 1, and an empty circle when it's a 0. And then that's it, and then it puts the date and time below. So it's really straightforward code. I'll put this on my GitHub if somebody wants to play around with it or change it or make their own version. That's fine. But I'm quite happy that this is working now, and as soon as I get the real-time clock in, I can put it into the face that I'm 3D printing at the moment. And so nice little mini project. It only took a couple of days to get it all working the way I wanted, and I'm very, very happy with it. And it's probably going to take me longer to print the plastic covering than it took to write the code, but there you go. That's the way it works. Anyway, that's it for me. It's just a quick, simple video. I hope you like this sort of thing. Please like and subscribe and all that good stuff. And thank you very much for watching, and I'll see you later.